And we have, what is the Lewis structure for dichlorodifluoromethane? So as you can see in the picture, it's already given to you, but let's see how they got that picture. So we have CCl2F2 Lewis structure. Okay. And before we delve into that, actually, I do want to just review the whole nomenclature and how that big name dichlorodifluoromethane just ends up being this. Because you have to remember that methane is just CH4. Okay? This right here is methane. What pretty much this is saying is that we went ahead and replaced every hydrogen with a chlorine or fluorine, and just happened to be two of them. So dichloro, difluoro, and still methane, because we still had that carbon in the middle. We just replaced the hydrogens. So that's how they got the name, just as a quick nomenclature review. But let's solve the actual Lewis structure. So carbon, being on the 14th column, has 4 valence electrons, okay? And chlorine and fluorine, being both on the 17th column, each contribute 7 valence electrons each. So 7 times 4 is 28 in total, and 4 plus 28, that's 32 electrons we're working with. So now let's go ahead and draw this out. We have carbon in the middle, and we have fluorine, fluorine, chlorine, chlorine. And now I'm going to fill in the shells based on their valence electrons. Fluorine right now is sharing 1 of its 7. So it's going to be 2, 3, 4, 5, 6, 7. Same thing here. 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. Okay? And now, with that being said, let's check to see if our formal charges are good. Alright, with that, carbon, I didn't bother to go over how much it was sharing, because as you can see here, it is just sharing 4 of its 4, so it really can't add any more electrons. But if we discuss formal charges, carbon, formal charge of 0 is where it has 4 bonds, which is what this carbon is doing. For chlorine and fluorine, they like to have 3 bonds. Sorry, I always get those two mixed up. 3 lone pairs and 1 bond, okay? Which is exactly what each chlorine and fluorine are doing here. So everything here has a formal charge of 0. And now for the last 2 checks, if they check the Octet Rule, and also we have actually 32 electrons. So the Octet Rule, as you can see here, it's good to go. Carbon and the chlorines and the fluorines are satisfied. Now in regards to the electrons, we have 4 bonds, so that's 8 electrons, and then we have 6 times 4 lone pairs, which is 24 electrons. 6 times 4, sorry, 3 times 4 lone pairs. I was already counting on the electrons. Well, there's 3 lone pairs on each outer atom, and times 4 of them, so that's 12 lone pairs, so that's 24 electrons. So with that being said, 24 plus the 8 electrons from the bonds, that is indeed 32. So this is our most stable and proper Lewis structure for dichlorodifluoromethane. So this is indeed correct. So now let's move on to question number 5. Okay. For question